All right, let's not waste too much time here today. Let's get into, we are doing the Professional Linux Users Group Linux Systems Administration Unit 16. We are in the final week. This is the final one of these that we're doing, at least for these. These will always be stored up in our Discord and people will always be able to do them, but the actual certifications that come from doing the course the first time will only be able to be achieved up until January 19th of 2025. So people that want that, people that want to shoot for that goal, it would be a whole lot of work right now, 6 to 8 hours a week for 15 weeks back. But let's get into it. So this week we are doing Linux Systems Administration Unit 16, and the announcements. This is our 16th class meeting. If we had any assignments or reschedules, we'd put them here. Our exercise sheets are all being turned in at once when you're completed, along with your projects, so we won't worry about any of those. I was having you turn them in each week, but then we just had so many people that it didn't even make sense to keep doing that. All right, last week we were dealing with troubleshooting. We hit troubleshooting from an incident perspective of, something that an administrator is going to deal with, and then we also dealt with it from like an engineering perspective of like what happened in the past and how do we keep that from happening again. And then we just kind of moved through all of these different topics. So, we talked in one of the discussion posts was your company wants to bring in Six Sigma. So you started to learn about cleaning up your desktop, which, by the way, they're not just talking about your desk sitting here in front of you. They're talking about as coders and people who work in an integrated development environment or whatever you're doing, wherever you're working. If you're working in GitHub with other people, making sure your workspace is clean, right? That kind of stuff. So there's a lot of stuff that even though it was written, I mean, the Six Sigma stuff for all that was written before, good coding practices were out there and before that was widely used. It's still applicable today to whatever workshop you're doing and whatever you're doing. And then we talked about visualizing data. Now, we did visualizing data and monitoring many, many weeks ago, but we were talking about like how does your team approach the presentation of data and that kind of stuff. So those were the discussions from last week. We had a worksheet last week, and I think we didn't have a lab last week because I was going a little easy on you guys. And then the project, right? You should almost be done with the project. This week, we're not going to have any discussions, but you are going to have a lab. We'll walk through the lab because we did it last night, so there's no reason for me not to show you guys in the recording. However, when we did it live for the live meeting, the guys got to work through and troubleshoot with each other. I just kind of sat back and was quiet the whole time. We're going to do 3 incidents. We're going to go through 3 different incidents, and we're going to work through them and see what the answer would be if we were trying to troubleshoot them. For you guys, it'll be a little easier because I'll have the answers there as we're doing it, but it'll be a valuable thing to kind of see. Okay. The topics of the discussion this week then will be incident response. There's a lot of different things to know about incident response, but one of the things that I always tell you guys is the more prepared you are, like right now, you have to know how to use your tools. You need to know how to check things and verify and validate. But there's a lot of stuff that you can do before an incident happens to make your life easier when that happens. And then we'll do our incidents, our fixes of some live things, which will be, we'll fix some web servers. Well, a web server that's busted from the other ones. We'll fix a disk partition problem. Some disk is wrong and not correctly seen by our system the way that the trouble ticket comes in and says, hey, you need to fix this. I don't know how it got there. That's not the thing. We need to get it working right. And then we're going to update some repository issues within our system. So those are our kind of 3 big ones. And that's mainly because patching's not working. Patching's not going to work until you fix your repo, make sure your device trusts the other devices, and all those kind of things. So, all right. So the incident response lifecycle, this comes from, I actually have a security talk that I've done on this. I've done it a few times on stream here, so you guys have been able to see it. But what do we need to be thinking about with the incident response lifecycle? Well, we have to think about our response capability before we even have an incident, and that's around policies, procedures, and a team. Who are we going to call? Who's going to be the call out? Do we have an on call, and then do we have an escalation policy? But policies and procedures are 2 things that I tell you guys all the time. You need to go to like sans.org and start planning and building out, because let's say you work for a smaller company and there's no hard-coded policy for like acceptable use, or there's no hard-coded policy for what to do in an incident, who to call out. Well, expect it to look like people are just running around like, like they're on fire, and they're not, and nobody's putting them out. They're just running around. So policy is one of these things where you need to have a comprehensive set of policies around what should be happening in your environment, right? And then procedures are those rubber meets the road type things where we talked about, and we've talked about this quite a bit, but I'll pull them up for you guys here. You go over here and you go to like SANS.org. I think I have these up over here. SANS.org, this is their acceptable use policy. And you can download this. It says right here, you can use this for your organization however you want. There's no prior approval required. You can just use it. So let's say you don't have an acceptable use policy. Well, you can start from scratch, or you can start with something that SANS.org has used. Very similar with your procedures as well, where I show you guys there's all these procedure lists. Now, you don't just want to go grab your server administrator one and plop this down on a table and say, okay, this is how we do server administration troubleshooting. No. You need to go and look at it and go, okay, well, we probably should check the logs, and we probably should see who's logged in. Yeah, this will be a good thing for my junior engineers or my bridge personnel, like our NOC operators, to be able to go in and do some of these commands to check what's going on our servers. Maybe even make that into a script form. But the point is, you have to start with something first, right? So you get that. And then the incident response and handling, like, how do you triage a thing? How do you say if two things come in that one is more important than the other? Who makes that call? Is it me as the systems administrator and engineer, or is it a manager who knows more of what the business impact analysis says and what the business continuity plan says, and they have the right call on whether the web server that's not customer facing or the database server that's a back end to something that is customer facing, which one's more important, right? So I want you guys to think about these things, right? If you're doing this course, and if you're wanting to be a server administrator and keep servers running for people, those are things you need to know. What about investigation? What's happened on the server? Nowadays, investigation kind of really takes two parts, because if I have a server that is either, there's an incident on a server that's an immutable server, if I build immutable workloads, or if it's a pod and it's an immutable workload, or if it's a server that's what we call a stateless node. Sometimes our investigation comes in the looking at logs later, and the most important thing to do is get that thing working again. So we just reboot it. We just reset the pod. We don't care. We're not looking in the rear view. We're just going, right? And that can have some value in the initial recovery of a system. And your organizations are always going to build to your recovery point objective and your return to operations objective, right? Those are the two, or recovery time objective, some people call it. It's RTO and RPO. And we've talked about that before, so we're not going to handle that too much now, but those are concepts to kind of know about. You recover and you repair, and then you debrief. And then what's the mitigation to limit the scope of the initial incident, or what is the mitigation to keep it from happening again? We need to also document all of these steps so that they come back into our policy and procedures to try to keep stuff from happening again, right? So all of this incident response lifecycle starts to, these are just individual components of it. It starts to look something like this. You get incident detection, something happens. We identify, recognize that an incident has occurred, and we start logging to record the incident with essential details like timestamps. I always tell you guys, I keep a separate page, and it may seem a little silly. This is just a page we were working on the other day. If I got called out right now while I was talking to you guys, I would open a new page and I would say Scott called out at 5:02, got on the system at 5:03, began troubleshooting, whatever. And that would be like my timed log, right, of what was going on in the system. And I would do it right here in Notepad as I, jumped up onto the system over here and did whatever I needed to, right? So I keep a log of what's going on. A good tool, like if you have like Teams or something like that you're calling into, or Slack, some people use Slack. You should be keeping track of what's being said, what's happening, and who's reporting back in from your different teams, right? Then as the incident's detected and logged, logs are always immutable. That's very important. And they are always timestamped. That's important. Incident classification and prioritization. Prioritization is a function of triage. What is the thing that we're going to focus our energy? We only have, we called everybody out and we have 3 people on the call. It's late on a Sunday night. We got to figure out, if there's more than one thing, we got to figure out where we're going to put things out, and we're going to do whatever. We're going to categorize things. Categorize typically means to order things in a certain way, and then we're going to determine the prioritization or the urgency. Now, you might say, Scott, I don't know how to do that. I don't know what's most important in my company. Well, the way your company should know how to figure that out is they should be doing things, there's security functions called business impact analysis and business continuity plans. Business impact analysis says, if this process right here, we've got this process, somebody can come to our web server, they can buy stuff and they can pay us money, right? They can pay us money through some credit card transaction that we have. Okay, good. If that stops and that's down for an hour, what does that cost the company? $100? It's not that big. I mean, that's not that big a deal. That sucks, but is it $1 million? Because some companies, that's over $1 million, right? Like you take Amazon down for an hour, that's probably tens of millions of dollars of money not exchanging hands, right? So your prioritization comes from your business impact analysis. Like, I don't know. I mean, I keep a bunch of I just keep a whole bunch of Linux servers running, right? That's always been my job, Linux and the networking and the back-end storage and all that. But those servers have names, and then there are applications on them, and those applications are doing things that make the business money. And we have to, as a security function, business impact analysis, that's an actual term, BIA, business impact analysis of what happens if this swath of my servers goes down, right? All right, then we start to do some diagnostics and response, preliminary investigation, and our initial response, right? Gathering information about the incident to understand its scope and potential impact. These things should be happening based on your incidents or just knowledge that you have, where you go and you just start checking your systems. It should be, hopefully if they're calling you out, they're telling you exactly what systems are affected, but maybe you find that it's actually going bigger. It's a bigger thing. They had found one little thing, and now you go, no, it's actually all the certs on this server are deprecated, and this server's functioning for multiple other things. We need to get more people on this. Like there's other problems, right? So sometimes you find in the preliminary investigation that something is causing more problems than what was initially captured. So that happens. Incident investigation diagnostics. I think root cause analysis is something for later. I think you get the system back up and running first, but this is going to be these things, how are you going to do? I'm not going to tell you how to bake your cookies. I'm just telling you things that you can be doing. Root cause analysis tends to come later, unless it's very obvious. If it's very obvious and rebooting that server is just going to net an effect of a problem right away again because this problem is going to keep happening, then yeah, root cause analysis right there should happen, and then we should fix it and reboot the server or whatever we're doing. And then we diagnose, identify the specific technical or operational issue that has caused the incident. Sometimes to get to our diagnosis, we actually have to spend some time doing some of those other tasks that we've talked about in previous weeks, where we're stepping through the OSI model and we're trying to bring things up and do these other things. How's it going, Pessa? We're just recording the last Unit 16. This is the last Linux Systems Administration course that we're recording. And then the course will be done, and it'll finish up on January 19th of 2025 for anybody that wants to try to finish all the work up until then. All right. Anyways, we get over here to resolution and implementation. We take our corrective actions. We implement the necessary fixes or workarounds to... Now, here's the thing about fixes, right? And this is an interesting thing. When we say fixes or workarounds, how are they different? Because some of you might be thinking like, Scott, I don't really know the difference. Isn't a fix and a workaround? I mean, it's just a way to keep the system kind of running. That typically, sometimes workarounds are called stopgaps. Well, it goes like this. So, like, me and Michael Pessa used to work together, and we had a build process for our servers, right? Devs could push a button, server came out. Okay, let's say on a set of their servers, though, a set of servers for a certain set of devs, they found that, let's say our certificates were failing in 2 weeks. The certificates that were there that were going to go touch back with some tool that we have in the environment were expiring. I say failing, expiring in 2 weeks. Well, I could fix those servers there, but that's only a workaround or a stopgap until I go back into our build process. And the next time a person pushes the button, servers come out with good certs. Does that make sense? So that's the difference. Is one is like, I'm just going to put this stupid little spare tire on the side of my truck and get it down the road for 50 more miles so I can put a real tire back on it, because I just need to keep the servers moving, right? It's that business impact analysis stuff I was talking about, where this thing being down costs the company real money. We have to get it up even if it's limping along, and then go from there, right? And that's a little bit of a, like, hopefully a server that the devs push the buttons on. Those tend to be like dev servers, not prod. So they tend to not deal in the exact scenario that I just gave. They're not customer facing, but the point is the same, right? We have to understand that. And then preventative actions. Could this have been prevented, right? I can't tell you how many times VAR has filled up on servers where if we had just been monitoring it, by the way, we're almost always monitoring it, but we tend to not be alerting on it. Or if we're alerting on it, we tend to be alerting on it so much that people just go, that's that alert. That alert's always going off. No, we need to fix that, right? And there's like 3 things busted there, right? But preventative actions is, how can we keep this from happening again? And actually, one of the ones that we had was me and Pessa. I remember this was when the servers were filling up in some of their because we had the servers all carved up for CIS benchmarks. There's a whole different talk on that. But CIS benchmarks caused our servers to have these really tiny little directories: temp, var, and they could fill up. So we gave Ansible playbooks to our bridge people who were watching the servers, and they could hit a button and they could clear those directories out. And because of Tower, it could give them root key access, and then that root key access, they didn't have to know how to delete a directory without actually deleting the directory, right? Don't want them to actually delete that directory off the server. But anyways, my point is preventative actions, right? Like knowing how to do that. And then incident closure and documentation. Formally closing the incident. Incidents always have a discrete life cycle, so they start and they close. And then when they close formally, typically we call that the resolve time of an incident, right? And then when we've resolved an incident, we take all the incidents that we've resolved over the last year, like if we're on an operations team, and we can get our mean time to resolve. So from the time that an incident was detected, but not just that, it's all the way back to when it started happening, which is sometimes earlier, we get our mean time to resolve. And let's say our mean time to resolve an incident is 15 minutes and 30 seconds. Well, we now have a goal to shoot for the next year, right? We've got like an azimuth, and we say our goal maybe as a team is to have incidents resolved in under 12 minutes. And you say, well, why not just under 15 and a half? Well, because some are going to be huge outliers. You're going to have some incidents that take maybe like a day. So if I can have many incidents under that, I can bring my average down, right? Because obviously you've got that. Now, let's say we're going into stuff that we've talked about before, but I'll re-hammer it out. Let's say our mean time to resolve incidents is 15 and a half minutes, right? But our mean time to detect, so the team that's detecting them doesn't see it until 12 minutes in. So problems have been happening on our servers for years, let's say, and they're not detecting it until 12 minutes in, and then they call us and it only takes us 3.5 minutes, but we're on the hook for all 15:30. Well, now we need to figure out how to get that logging and detection to happen faster. We need to trigger alerts better. We need to train that team better, that team that's probably separate than like the systems admin and engineering teams. So that's something to think about as you're going through this and doing it. All right. And then you always have your after action reviews, AARs, or post-mortems, or post-incident review and analysis. I mean, there's so many terms for this. I've even heard that we don't use post-mortems anymore because it offends dead people. I don't know. But the point is, some companies don't use certain things anymore. But post-mortems, the way I had always heard it, or after-action review, and we conduct a post-incident review to evaluate the effectiveness. Where was the long pole in the tent? If the critical path from detection to resolution was that was very short, but it was the time to detect, that's where we need to spend our efforts in the future and get that down. Was our response time good, but it was only good because we called Michael, and Michael knows how to fix everything because he built it all. But when our other engineers get on, it takes them like 4 or 5 times that. Well, that's not good. What we should do instead is figure out how to train our users, train our team, make sure that we're maybe not even cross training, but some of our members of our team are working together better to, because maybe he's got a KB article that's great. And he goes, yeah, I just reference my knowledge base, my KB article every time. But nobody else knows where his KB is. That's just as bad as it not being written, guys. Okay. All right. So we do that. We do analysis. Again, sometimes that analysis is taking a hard look at how good are your operations as a team really going. And then once we identify that, we can start to deal with risk. Like, how risky is it to implement a new service when we're really, really bad at getting these other ones up? So we can start to talk about business risk and stuff. And then continuous improvement, right? We shoot a better azimuth and we move that direction. All right. So lab tasks this week, we have these 3 lab scenarios that we're working on. And then questions, if you have questions, ask them down Discord. Let's get into our lab scenarios. So here's my environment. And here is my, yep. So the very first one is a ticket has come in. Whoops. This one's a ticket's come in, and the web server's not running on the web server, right? You've got a server, and the web server component of that is not working. So let's go figure that out. By the way, I got to go access. Where do I got it? I got it over here. My actual username and password for this. So on this box, I need to go to tshoot one at, and then it's my own machine, right? So it's just tshoot1. Oh, whoops. It would help if I SSH'd over there. All right, and then what's my password for this? It's something. All right, and I'm going to go into the 2 lab, and this is troubleshoot 2 or troubleshoot 1, sorry, but it's the second lab for troubleshoot 1, and we're going to go figure out what's wrong with this web server. So let's make sure uptime. It's been up 1 day. Let's do system CTL status, HTTPD. I just want to make sure the server's dead. Okay, yeah. So we've got a server. We're on a server. This is supposed to be a web server. We can do an RPM-QA, grep-I for HTTPD, and we see that it's got the packages. Hopefully, we could even cross-reference that if we knew where our web server levels were. I don't like to necessarily cross-reference stuff like that live. I would go check on another server. Like, hey, is that updated to the level of this other server that's like related to it, right? But anyway, so we got a web server running. We've got that, and they really just say a ticket has come in the other lab. So you guys can download the labs in the Discord. In the other lab, it says that for this to be done, there's 2 things we need to do. We need to fix the web server so that port 80 is accessible from outside of the server. So we're doing the lab that we did yesterday as a group, right? But we need to turn it on. So if we did an ss-ntulp and grep for port 80, this server should be running port 80. This is not, that is something else, that's Promtail. So we don't have a web server running. Well, we know that because it's disabled, but that's fine. So let's turn on the web server. System CTL start HTTPD. Let's just try to crank it over and see if the web server starts. I'm gonna press up a few times, and there's my status. I've got a server running, and if I go and I look at it again, ss-ntulp, I see that I've got a web server working, but it is not on port 80. It is on port 8087. So this thing over here says that the server must respond on port 80. That's a requirement. That's where we redirect. That's where our load balancer knows to find it. You can't just be, saying, well, 8087 has an 80 in it, so it's good. No. Port numbers are exact. If you're connecting on TCP something from the back end of a load balancer, or you have a redirect, or you have whatever, you have a proxy to it, like, it doesn't matter what you're doing. By the way, load balancers are basically just reverse proxies, right? That's all they are. Instead of a forward proxy where you go out through some device to get to the internet, it's the devices are coming in and connecting to a device, and it's sending it to one of multiple backends. That's a reverse proxy, right? Well, anyway, so we need port 80 open. There's no playing around there. So we need to know where that is. So we need cd to etc HTTPD. We need to know that this is where our configuration modules are, and then I can go to like conf.d, and in here, it's conf. and then in here it's httpd.conf. And if I just grep for like listen out of httpd.conf, I would see that we have listen commented out, and this is the listen of the port that's being used. So if I knew nothing else about this, I should know that I probably can just flip those and make it work. But hold on. When the server was first installed, somebody had the wherewithal to copy, right, over to an orig. So I could also do this if I was troubleshooting. I could diff my httpd.conf. Now the things are going to be on the left for this one, and httpd.conf.orig, they're going to be on the right for that one. And here's our difference. In the original file, the uncommented line was 80. And in the newer file, well, the active file that's actually being read, it's 8087, which also, by the way, aligns with what we see up here. So if that's not what I expect, I have to fix this, right? The standard is we have a web server running on port 80 in our environment, and this server, for whatever reason, I'm not going to get into forensics now. I'm not going to go try to figure out who changed what or go start calling team members out. Maybe it's, you know, midnight on Sunday night and I'm trying to get back to bed because I got project work to do tomorrow. I just want to get this incident closed. So I need to get this working, right? So I'm going to VI my http.conf file. I'm going to /, oh, well, I'm already on listen. And maybe I'll just comment this out because, look, it's not that I can't just blow somebody else's work away. I'm admin. I can do whatever I want. I'm root. Fuck, I have all the power in the world. But maybe somebody changed that for a reason, and we're gonna find that reason out later. You know, we're gonna probably have some meetings over this and do some of those post-mortem things. But for me, for now, I know the standard is we have to go back to port 80. I don't know why that changed. We're gonna probably figure that out again, like I said, later. But I'm gonna do that. Now I gotta ask you guys something. I just changed it in the config file. Is it going to be set here correctly? Am I going to see the web server, just because I changed the config file, is it going to be seeing the correct? And if it's not, why is it not? I want you guys to think about this because this is a very important part of troubleshooting. You got to know how your services work. There's a lot of ways for, because you might say, well, I write code where it goes and updates off file in real time, and I say that's awesome. In the server side of the world, the way we chose to do it for stability reasons is we don't read things in real time. What if I had been doing this and I was typing it and I saved it and went to lunch and came back, but it only had the word list and I had already commented out the other one and it was reading in real time, and now I have a broken config and the server can't run anymore. So for stability reasons, we've chosen to not read config files in real time. We tend to have to trigger the reread, like Tomorrow said, with a restart of the service. So, restart, HTTPD, go look. Now we've got a listener on port 80. Now the server's doing the things that we want. By the way, I made a mistake. Let's look at our status on the service real quick. I could just Control R, but it's fine. We'll press up a few times. This service is disabled, so we also need to make sure that HTTPD is going to be enabled in the future. Now there's one other problem on here. System CTL status firewall D. Firewall D is also running, and maybe internally in our environment we don't have a standard for firewall D to be on. So I'm just going to, for now, turn it off, because if we do firewall CMD, we can see. Let's just do help real quick. What? -CMD. Let's get help real quick. We can get all the rules that are currently there. I think it's a list rule. Right? I don't use firewall as much, or I haven't looked at it in a while, but we can come in here and we can see what the active zones are, what the active protocols are, and all that stuff. So let's go here and say get active zones. We can see what active zones are there. Should be public, and then we can get the services, right? So Whoops, didn't mean to do that. Pull this back up, boom. Get active zones, and that's also where it's at, and then get active services. And, whoops. I thought it was get active. Did I just get that wrong? Might just been get services. Yeah, that was my bad. So now with that, we'll see the service get active. I thought it was. We can see all the services that are there. Where's it at? Get services. That's all the predefined one. List services. Somebody help me out here. It might be list services. Yeah. So look, these are the ones that are being allowed into the server on the zone applied to ETH0. So I only see cockpit, DHCP v6 client, and SSH being allowed right here. So that to me says that I would have to allow port 80, either as the web service, which is probably HTTPD if we were to look in here. But this isn't necessarily a firewall lab, so I'm just going to say systemctl stop firewall D, right? I'm just going to stop it. And then now I would reasonably be able to say that firewall D is off. Yep, stopped. And my system is listening on port 80. Yep. And I can curl 127.0.0.1 on port 80, which is the default. And I see an Apache. So, okay, my server is running. Everything's good. So that's the first lab, basically. And we troubleshot through that yesterday. And I think people had a good time with it. But it was to go in there and see, you know, this server that got built was pretty mucked up and it wasn't doing all the things that it was supposed to. So let's go look on the second one. So we're supposed to reboot this machine when we're finished. So we'll reboot and it'll kick us out. And we're going to go to the tshoot2 user now. And the tshoot2 user, I am going to go find my password for him real quick, which is... And we'll go to 2. And we're going to reboot him because he wasn't rebooted since the last time. And let's go check the other one. Oh, he's been rebooted. All right, good. So this one will be in a this one will be in a good enough state for what we need, I think. Yeah. He's at least cleaned up from that perspective. No, maybe we'll wait for the other one to come up. Give it a second. We got to give it a second, guys, for this other lab to come up. But here's what this lab is going to say. A ticket has come in that amount point /space is not working correctly. So some team asked for a server. The team expected a 9 gig partition to be built on there with the 3 attached disks, but found it wasn't on a separate partition. So, you know, we go into this user here. I'm letting that server reboot real quick. We can watch it reboot real quick just to make sure. So that was 14. Where's he at? Rocky 14. Make sure he comes up to a good working state, and then we'll go. He should be almost ready right here. I'll go. The Bastion doesn't have a wait timer, so I can't go into the Bastion server. I only have 10 seconds before I jump over into a node. So I'm going to make sure that 14 comes up, and then we'll jump into them. So and then we'll go and we'll do the lab on there. So the goal of this lab again is going to be, you know, you got called out. It sucks to get called out for things that were built incorrectly, but sometimes this happens, right? And Again, this is one of those things where I'm going to be building this and doing a stopgap, but this might not be the exact way that we would do this in the enterprise. We would probably take this immediately back to the team that was, purposing to build servers and go, why are the servers not coming out right? There's options to build things, but those things aren't getting built. Then they have to go through the logs and they say, oh, well, there was this, this thing busted in the Ansible and it just didn't continue. And we say, well, now we need to figure out, do we need to add some error checking in there? Do we need to add some failed when false so it just blows through it and then reports? You guys can, this is something that we do a lot of the times. You might say, well, I don't think Ansible should continue if a server doesn't build. And I say, well, that's probably true. It probably shouldn't report that it was done like it did here and then the team get on it. But what could happen is it could finish the rest of the build, report out the thing that didn't work, so now we can go start working on that. We could come in and we can one-off fix the server and then kick off the email to tell people like, hey, your server's ready. One of the worst things ever is to have your users tell you that shit you're doing and building is wrong. I don't want to say it's the worst thing ever, but that's an unprofessional thing, right? You should find your errors out, not other people, if you can avoid it. All right, anyway, so let's go in here. We're going to go to Rocky 14. So it says I'm being Rocky 14, and we say uptime. Yep, that's a lot better. LSBLK. Those block devices are still there. VGS, LVS, they're still there. So we can get rid of them and clean them up, as it were. That's fine. So let's we could do that real quick. Let's say we wanted to clean this off. I'm reusing servers. So PV, so VG destroy. Sorry, LV destroy. I think sounds right. Remove. Yeah, there we go. LV remove. And it should probably be the full name, so dev mapper. There we go. Yep. So we'll remove them, and then we'll do VG remove of the same thing, C, C, O, and X. Get rid of that. And then we'll do PV remove of all of the ones that are in there, so dev XV DB. C, E. Super easy, right? So now when I do PVS, VGS, LVS, these are just, these aren't doing anything anymore. There's nothing going on in this environment. XVDA, different. We don't really need to worry about that one. But now we need to build in the mount point space. And is space even on this box? It's not even there. So we need to make the directory space so that we can mount things. And then we need to start a set of processes over here that get the disks in the logical volume management. So there's a few ways to find the disks that are on a system. You could do LSBLK and see what disks are there. You can do fdisk-l grep for XVD. Excuse me. So I see an E, a C, and a B are the 3 gig disks. I don't know what mappings they're gonna get when they come out, when they come tumbling down that chute of oh, it's spelled shoot right. Last night I said shoot and it said SHOOT, but it's CHUTE, right? So it's a chute, like comes down the chute. So we have these 3, B, C, and E, and really we don't care what order they get assigned. But let's add them to we do a PVS, they're not there. We do a VGS, they're not there. We do an LVS, there's nothing there. So let's do a PV create. And we can PV create each of those disks. So dev XVDB, C, and then it should be E, right? Now we do a PVS, and we see those 3 disks. I don't know why A was jacked up, but we see B, C, and E. Those are the only ones I care about. I don't care what A is doing right now. And then I do a VG create, and we've added the 3 disks that are there to the physical volume management, or the logical volume management of the system, right? So it's LVS, logical volume, LVM, logical volume management, and we've added them in. So now it knows that it can use them. So now we're going to give those the capability here to, we're going to push them all together and make them one volume group. So VG create, and we're going to just call it space, let's say. Doesn't matter what we call it. And we're going to give it dev xvdb. And we could do this a few different ways. We can actually wildcard expansion it, or we can just do b dev xvdc and dev xvde. And when I write out procedures, I tend not to do the wildcard expansion of things, and this is why. One, I don't know that they're going to be the exact same disks, so if I were to write that, people are going to have a hard time rewriting the wildcard expansions if they don't understand what's happening. And two, I could just say VG create space and then say each of the disks, right? Which I think I actually say over here. Like, so just do each of the disks, right? And then the last one's going to be an LV create, which is going to then carve down from that volume group the slice that we're going to give over to the space volume. So we're going to say LV create space. I've got my little cheat here, and we're going to call that space as well. Whatever, why not? And we're going to say use all 100% free in the system. You don't have to use all 100%. You could use 90%. Now, we are trying to give them 9 gigs, so we do have to use all 100%. But in some disks and for some reasons in the enterprise, you may only give them 80% and then expand it later. That's a common thing, right? And then maybe we do a space VG as the name. That was if I had named it space VG. The name for this one is going to be space. Yep, and then, I'll just go space, whatever. We're going to wipe it, so we'll just allow it to wipe because it did have a file system on there. And then we're going to go ahead and say, okay, so PVS, VGS, LVS, we have all the things that we expect. So now we should be able to test. We should be able to say, well, one other thing. We need to make a file system. Maybe we do ext4 on that dev mapper space that we just created. So space is the volume group name, and space is the logical volume name. A lot of times I'll do space underscore VG, and then like space underscore LV or something like that. But in this case, it's just space space. That's the volume group, and that's the logical volume. So, all right. So we created that. Now we should be able to just mount, real quick again, df-h space. It is mounted off of the root of the file system. If we mount and grep for space, there's nothing there. Then we do the mount command and say, okay, put that dev mapper space on /space, right? Do a df-h, we see it down there at the bottom. And if we do mount and grep for space, we'll see space is mounted as an ext4 type file system. So that's great. But it says here that it's not set up correctly and we don't want to see this again. So what I did right there is a very, very temporary thing. If we reboot this server and it comes back up and it was a physical box or a virtual machine, this would not be mounted anymore because I only mounted it this time. So we're going to umount space. We're going to get it off the system. Space. We're going to get rid of space. And then we're going to, we just grab this real quick if we want because they'll have all the information we want. VI our etc fs tab file real quick. And if we shift G and then O, we can just add, and maybe we say add for trouble ticket T-shoot 2. Right? So add for trouble ticket T-shoot. And I'm going to add it in, but it's going to look just like what we see up above. So it's going to be dev mapper space. That's going to be the mount point. Then we're going, that's going to be the file system on the left. Second one is going to be the mount point on the system, how the system's going to expect to connect to it. Then we're going to have our ext4, which is the file system type. And then we don't need those. We could leave those, but let's just say defaults. Say default or defaults there, and then 00. I asked yesterday if anybody knew what the 00 was for. We've talked about it before in earlier labs of these, but I'm going to write that. And now I'm going to do a little thing. I'm going to go check for my... Where the heck was it? Grab for space that's not there. And I'm going to do a mount-A. Now, mount-A is going to go reread etc tab and try to mount everything if it needs to. Ah, it says that there's a problem. But let's real quick just see if space is there. Space is there. Now, this is a newer thing that kind of came up, and I was kind of curious if I could just blow by it. You should do a systemctl daemon reload nowadays for that. That was never the case back in the day. But we'll go ahead and do a systemctl daemon reload. So the sysctl will reread the etc tab. But our mount did work. So our mount is there. Now if we do a df-h, the file system's there. And because we mounted it this way, because we had removed it, added an etcfs tab, and mount-a it, it's an old sysadmin trick, now I know with confidence that this server will boot and mount that without breaking anything. So if you ever wonder if, oh man, shoot, I did like 5 mount points and I'm not sure things are going to work, just unmount them all and do a mount-a, and it'll go reread your file system, your etcfs tab, and it'll tell you if it's right, because it'll look almost like you're booting your system. And you say, well, is that really that important? Guys, your etcfs tab breaking, so your file system breaking when your kernel comes up and hands off from initramfs and goes to actually boot the kernel and go live on its real file systems, is probably one of the most insidious type of errors you can run into. You do not want to be in the business of having servers that don't boot properly. It's just a nightmare. Going down into rescue mode or even putting a different ISO on the system, it's not a disk anymore, but like an ISO, and actually having to troubleshoot why a server won't boot, it's a nightmare. So just always check your stuff like this first so you don't have any problems. All right, so that's that lab. That we did everything in there. All right, and by the way, when we were doing this, the people that were running it, we were supposed to have like different people doing labs in different places. They had hints, so they could give hints or whatever. All right, so now here's the last one. We're going to reboot that lab machine. It's going to kick us out, and we're going to go into tshoot 3 now. tshoot 3 has a different password I got to go find. Give me a second. By the way, all the passwords, all the access to these labs are up in the Discord if you guys want them. But tshoot 3 looks like this. Where's he at? It look like that. And we'll go into Rocky 16. I'm going to say uptime. How long has he been up? So somebody's rebooted him recently. That's cool. Let's make sure nobody else is in here with me. Good. And let's make sure that if I do a DNF update, it should tell me that nothing's there. So let's go look at what the actual problem is in this lab, because some of you are probably like, well, what's the problem? What's the thing that's busted in this lab environment that you guys are doing? Well, here we go. Your team is trying to update a bunch of servers. So you're doing some server maintenance window. It's Saturday night, you've got your pizza, you got your monsters, you're working, and you've done the, typically what we do is some kind of Ansibleized process that goes and pre-checks all our servers and then updates all of them, reboots them based on decisions of logic that you've put into it, and then at the end you get a report, and maybe these servers didn't come back up, so now you start spinning off, it's me and like 3 of my junior engineers, and we're making our different engineers go and like, hey, you guys fix these 4, these 4, these 4, these 4. And one of the guys on your team, this has happened to me literally hundreds of times in my career. Some junior engineer on your team kicks you over a server that they cannot get to update. So, people are reporting back. We're sitting there, you're watching Netflix because you're just watching all the other servers finish, and your engineers are going and grabbing servers off of this pile of servers that are showing up on this report. You're reporting them out to Teams or something like that we typically use. And one of your engineers just goes, this happens all the time again, Scott, I can't get this one. I got all the other ones. I tried all the other things, but this one is busted. And I say, all right, I'll take a look at it. And this is what we did yesterday. Some of you guys as engineers had to go work through this, right? And it kind of looked like this. So the system thinks that it's updated everything. Well, there's nothing to update, but hold on. If I do a DNF history, I see that this system hasn't been updated since the 29th of last month. So we're patching tonight. There should be updates right now on the server. The server's been rebooted recently, so you know something happened on it, but it did not take patching. So what could be busted? Now I'm the guy who busted it, so it's not nearly as fun for me to go look back. But what could be wrong? Well, a lot of times where we need to think back, where does DNF go get its repositories? Where does your system trust software to come from and then download it in your environment? Well, it happens to, and this would be a thing you'd only know if you'd been around a while, you'd probably think it's down in Etsy DNF something, right? But the thing is, DNF is it has come, I guess it'd be a post-successor, I don't know what the word would be for that, but it has come after Yum. So all of the repositories are down in Etsy yum.repos.d. And in here, there's some repos that may or may not be interesting to me. But if I knew nothing else about this, I might do a diff on rocky.repo and then go look at rocky.repo.orig and see what people have changed. And I say, wow, somebody changed on line 16 and line 44. I think that's what those are, but they changed enabled to 0. So they turned off enabled. So let's go look on rocky.repo. And let's go look at, well, that is the base OS. So this is all the OS stuff is not even enabled. And down here on the app stream, that is not enabled either. So that's not there. And then down here, there's some other stuff. Maybe none of these were already enabled. I don't know. But let's go ahead and escape :WQ. One other thing to do, by the way, is you could always go check against some other machine if you had another machine and diff those files, or at least go eyeball them and look for where they are or aren't enabled. I might do something like this. I might look for, I would think a easy search in this real quick would be like this. I would say grep dash capital E and then lowercase I. So dash E is going to let us do extended functions, and then I would allow us to ignore case, lowercase I. And I might say give me name and give me enabled, right, for the rocky.repo, right? And then I would see this, and then maybe I would compare that to .orig. Maybe it's going to fit on one screen, and I can just look and go, okay, does this look like the original? I don't, by the way, I can't assume I know who made the original file, so I'm kind of cheating. I know that I made it, but maybe you have something in your check script that always moves one of these repos off. And the reason, by the way, the reason this is important is sometimes, especially in your dev environments, your developers will get more power. Maybe some of them have even managed to get root on some of their servers. It's typically against the acceptable use policy, but you don't want to go fighting all the, you know, you'll spend all your time fighting dev managers if you do that. So what you instead do is you go, okay, and this is what we used to do. We moved everything out of Etsy yum repos.d every time we patched, and we dropped our version in. And you say, really? Yeah. Because developers break their own stuff. Look, developers are good at developing. Developers are not there to clean up their own workspaces as far as a server goes. So I've seen developers add hundreds of repos to shit that are broken later. Well, I don't even want to patch into your stuff. I'm just going to move all that off, and only things that are going to be in here will be my things. Now, I have we were talking about this after. I have some pre-check stuff down in our Discord on the Ansible code that I was posting yesterday, as we were kind of talking about this later. But I just want you guys to see that now, if I do my DNF update, my system thinks it's going to go ahead and update. Now it's got all these repos that it's got to go update its metadata for, right? It's got to go download metadata. And then now I'm going to go ahead and say no, because I never automatically update anything. And we're going to go look through here. They're alphabetical, so that's nice. We do not see, by the way, they're alphabetical, but these are upgrading. Kernel packages will always be installed. Kernel packages should always be installed. You should always install a new kernel and then move to the new kernel. You should never upgrade a kernel in place. That doesn't make any sense. So, well, it doesn't make sense in legacy stuff. Some of the newer stuff, there's like K patches and stuff. And I mean, I guess if you see that working, use it. I haven't really seen that much. But I want you guys to see, there's no kernel coming in here. So I could patch my system right now, and it would take about 10 minutes. but I'm not getting the kernel that's required. And you say, well, Scott, how do you know that you didn't update the kernel already? Well, there's a few ways. We do DNF history, and we don't see that the kernel was updated. We do a uname-r to see the version of the kernel that we're on, and then we do a grubby, I hope grubby's here, default kernel. So DNF install grubby real quick. Just ignore me real quick. Just ignore me. Like, don't look at the guy behind the screen, right? Now, here's our default kernel. So we don't even have a grub file. But suffice it to say, we're not going to a new kernel on this system. That's fine. Who cares? All right, so this server doesn't have a... this is a different environment, so it doesn't really have one. But we didn't see it here, so we know it's not installing a new kernel, and we don't see it up here. So something is excluding our kernel update. And the place that you can go find that is actually, interestingly enough, let's do an ls-l on etsy yum.conf. Yum.conf is actually over to etsy dnf.conf, so I can vi etsy dnf.conf, right? And in here, somebody's put an exclude kernel in our path, or in our configurations. And the reason that's important to know is a lot of times, as a sysadmin and a systems engineer, I will lock down kernel. I will lock down anything Mellanox, like that, because those are like my Mellanox OFED drivers. I'll lock down anything Slurm, right? And I'll lock down anything, what's another one? GPFS. So if you're going to try to do anything in my environment and use like an automated tool, even if it's got a repo attached to the system, it will not try to update those anymore. Well, I've now commented it out, so that's no longer the case. But let's go ahead and look at this real quick. Now I'm going to go do my DNF update again. And let's see if the system finds a kernel this time. It does find a kernel. So the kernels were being excluded, and that was going to be a problem. I had pulled this up. Let me show this to you guys. If you do want to go hang out in our Discord, you guys are always welcome to hang out down Discord. But these were some of the things that I was showing yesterday after, where we were talking about like patching servers and fixing those exclude lines and pulling them in and out, but only for certain types of patching. And then also this was like some of my checks of servers and those kind of things. So like these things are here for you guys to go study and get better at and practice and all that stuff. We have labs that show you how to do all that stuff. But that is, interestingly enough, does exclude package often cause dependency problem? Yeah, so that's actually interesting you say that. Yes, it actually causes what I call it, this is my own term, I don't know if this is the technical term, it causes a cascading problem of dependencies later. What does that mean? If we're not doing kernel patches this week for stability or this month or whatever, typically kernel patching is every 3 months, most places I've been, and you can change that policy however you want, depending on what we call the security posture of your organization, and also how well you can boot without affecting, your services. Where I'm going with that is, if you stay on a kernel, all patches going forward that are dependent on that kernel are going to be affected. So if I were to exclude kernels, more and more of these, as we kept going forward through time, would no longer be getting updated because they would be dependent on newer kernels. So that is an important thing to understand. Now, your package manager deconflicts those dependencies for you. We used to have to do that stuff by hand back in the day. But no, nowadays, but trust me, as a net gain, package managers are like one of your best friends from, if you ever go see some of the ways that we used to have to do some of this. Like to install something like Yum, it might have taken you like a few days to find all the dependencies and libraries and stuff. So that used to be a hassle, and that's mostly been deconflicted out of systems. But yeah, you can't stay on the old kernel forever and still keep support going forward. But you can do it for stability and whatever the posture is. I work in a lot of high performance compute stuff, and the high performance compute environments that I'm in tend to be air gapped. So we can get away with our kernels staying back a little bit for stability reasons, right? Anyway, so that's that. We see all of the pieces, and now I know that I would have been able to patch. So I would patch that server. I would go what I would do after that is, like, typically after like a long weekend of patching, guys, I would go in and we'd have a meeting the next week, and I'd sit down with. I've always had teams, like, I've always been the tech lead. I'd have teams of between like maybe 8 and 12, and typically like 4 would be on a patching weekend with me, and they'd be running off and fixing stuff. And this would be one of the things that I would go throw in my notepad on, 10 o'clock at night. We had this. This is what we did to resolve it, and I would make sure that got updated in our patching, monitor, not patching monitor, our patching documentation out on like a Wikipedia page or media wiki page, whatever you call your internal stuff, right? And I would, if I did the work, which I just did there, I would write it up. If I showed, like, if I had one of my engineers, we're on a call, drop off the call, because typically you have like a bridge, and I'll say, hey, we're going to go for like 15 minutes and work on something. I'll work with the engineer, and if I have them shoulder surf with me, I would show them the pieces, and then I would make them write the documentation. And you say, well, you're a monster. And I'd be like, well, but you know what? They're not going to have that problem again. And if anybody ever comes to them about it, they're just going to point them to the documentation that we fixed. So that's a thing that's important. We were also talking about, like, pre-checking your servers before patching. This was one thing that we talked about a lot. And one of the things is when if you solve the problems that are common beforehand, you will save yourself a lot of headaches. So a lot of times, if you df-h on like var cache, my var cache is part of my root. That is not going to be true in the enterprise often. Var cache is almost always going to be, for CIS benchmarks, its own partition. Well, let's say it's 5 gigs, and let's say it's mostly used, and you know that this is a big patching, so it's going to use over a gig. Well, if you just go through all your servers beforehand and make sure that their cache, you just check all your servers. It's a pre-check that you run in your Ansible, and make sure that var cache isn't full, or make sure that it's got more than 1 gig in it, and then report out the servers that don't have that as one of their, just report out the servers to yourself that don't have that. Maybe I should make that a lab. Yeah, actually, that would be a good lab. Build lab. Hold on, where do I have it? Build lab for... That'd be an Ansible lab. Right, so pre-check our servers before patching, minimize errors. Another one that I was showing the guys is you have this RPM. It's RPM DB, and then it's rebuild. Is it rebuild? I think it's something like that. DB rebuild. I think that's right. Hold on. Where is it? They probably have it here somewhere. Oh, rebuild. Yeah. What did I do? Rebuild DB. That's what it is. Did you know that if you're gonna patch like 100 servers, and I thought I just saw that right there. RPM DB -- rebuild. Oh gosh, it would help if I typed it right. Did you know that if you were gonna patch a bunch of servers and some of them had RPM DB problems, your YUM isn't gonna work, or your DNF isn't gonna work with them? It's just not. It's gonna break all over the place. So you go and spend a little time up front to just do an RPM DB rebuild in the environment, and report back any nodes where this doesn't come back as a 0, right? This isn't good. And you save yourself a whole bunch of problems there. Because we were talking about, and this is more on the, I guess this is still all admin stuff, is the Pareto rule, right? Pareto's rule says 80% of your problems are going to come from 20% of your inputs. Well, it says 80% of your outcomes come from 20% of your inputs. But Pareto's rule is basically this idea that, like, there's always a small little pocket of things that are going to cause you trouble. And you can minimize that pocket by understanding and building this. Hold on. It exited 0. Does everybody know that part of it, right? Exited 0, which, by the way, would be if you were to have kicked that off via Ansible or something, your returned variable could be there, and then you could just report out the nodes that didn't rebuild their database right. And that's going to take, like in my environment, it took a little bit of time. Sometimes that can take up to 5 or 10 minutes on each of your nodes, but that's a shared 5 or 10 minutes, so it's not a serial, right? It's not one at a time. It is parallel. It's all of them happening. So what's 10 minutes to me when I was going to have to sit and wait until 8 o'clock at night to start patching the servers, anyways, right? I might as well just, we get on at like 7. We're all getting ready and prepped up and talking to the different teams and making sure everybody knows that patching window is coming. By the way, that should all have been talked about well before this, but my point is you're getting on, you're making sure engineers are on this and this and this, and you just go and spend a little time kind of working on little stuff like that. All right, so those were the lab tasks. We did, from start to finish here, we did 3 lab scenarios. These are found up in our Discord if you want to go do them. On the other version, which is this is the one with answers. If you do the one without answers, it just tells you how to connect. It doesn't give you any other help. But if you want to go download the answers one, you can then go look at it. And what did we do first? We fixed a web server that was all kinds of jacked up. Somebody busted that thing good, right? We had to turn it on. We had to enable it. We had to put it on the right listener port. And then we had to turn off the firewall or allow the port through the firewall. You could do that either way. Then we came down here and some mount point was not properly set up. So we built the mount point. We built the disks by giving them to logical volume management and then carving them all up. So we did all that. And then we came down here and did what I thought was probably one of the more useful ones, which was patching. Now, one of the guys asked yesterday about, there was a question about he had seen a job, but it was like heavily into patching and he didn't feel super confident with it. So I will be doing a thing here in the future about just patching systems and some of the things that I've run into with that. All right. If you have questions, feel free to hit me up on Discord or, any of these other ways that you can reach me. All right. So this was our last recording. This was our week 16 of our Linux Systems Administration course. We've done, 16 weeks of it. It's all in the Discord. It's all free. If anybody wants to join it, there's our Discord. You guys are welcome to go hang out down there. All right. I am going to go ahead and stop the recording. So we'll go to our little end of stream. I'll stop the recording here. You guys are welcome to, again, hang out down the Discord as much as you guys like. And if I'm back on later tonight, it will just be working through, I might do a walkthrough of all the Linux Systems Administration courses that we've done from start to finish. So we will get to our little end of stream thing here. All right. We're not going to